Hi Year 9, it's Mr. Wilson here with a physics video for you. Today we're going to look at refraction of electromagnetic waves. Now, an electromagnetic wave, like light, travels at different speed based on the density of the medium that it's in. When I talk about medium, I just mean a material that the light is moving through. So classic examples would be air or glass or water. If it's more dense, like glass, the light moves slower. If it's less dense, like air or a vacuum, the light will move faster. Now, refraction happens when light goes between one medium and another at an angle. And because it changes speed at an angle, it turns the light beam in different directions. I'm going to demonstrate that for you today. So firstly, we're going to look at light travelling between air and glass. Look at that, how that changes the angle of the light. And then we're also going to look at how that affects different wavelengths of the light to create rainbows, which is very cool. So I'm going to turn the light on. I'm going to show you the setup, and then I'm going to turn the light off, and we'll see what we see. So I've got here a power supply. This is giving me an electric current, 12 volts, direct current, to, this is Mr. Raymond's lamp. We also call him a ray lamp, because it's a lamp that produces a ray. So when I turn this on, I'll get a single ray of light that comes out. We should be able to see it against the white paper, and I've got a couple of different blocks of glass that we can see what happens to the light ray. So let's get the light off and the lamp on. All right. So here's my lamp, and I'm going to try to keep the camera away from the lamp. The key thing that the lamp is doing for us is it's producing a single beam of light. Here I've got a glass prism. I'm going to put the glass prism straight on. We can see the light going straight through it. As I turn the prism, we can see that the beam of light is changing direction. I'm changing the direction of light using this glass, block of glass. What's happening is the light ray is travelling at first through the air, and we can see it against the paper. When the light ray hits this boundary of the glass block here, it slows down. And because it's hitting it at an angle, it's not hitting it straight on, it slows down and it pulls it round. So the light ray is going, hopefully you can see my finger, it's going straight, and then it hits the boundary, and then it moves in a slightly different direction. It does the opposite when we get to the other end of the glass. It's going through the glass. When it hits another boundary, which is just along here, I'm not sure how well you can see that, but that is the boundary of the glass and the air. It's going from, so here it is moved towards the normal, so it's bent more towards the normal of the boundary. In this case, because it's going through a less dense medium, it's bending away from the normal. So it was going at a steeper angle, and now it's going at a more shallow angle. So that's what happens with this square glass block now. I'm going to remove this square glass block, you can see the light, and I'm going to put in this triangular prism. Now this is one of my favourite ones. I'm going to take a while to set this up, so we've got a mix of reflections and refractions going on at the moment. Here we go. If I set this up just right, I'm sending my beam of light off. And just get this right. There we go. About there. So I hope you can see I've changed the direction of the beam of light. Now what I'm going to do with this, I'm just going to pull this back a bit actually. Oh no, it doesn't like it so much. Let's change the angle a bit. Go for an angle about there. About that one. Now what we should get with this, let's see what, I'll go for this one. Here we go, so I'm changing the direction of the beam of light. If I put a white screen over here in the beam of light, we can see the light's coming across here. We can follow the light along there, it's getting fainter and fainter, and then when we see the screen, I'm going to come in nice and close. I hope you can see I've got a rainbow on the screen. So I've separated the light into the blue, the green, through the yellows into the red. So the reason that's happening is that each light is made of many different wavelength waves. So many waves with different wavelengths. The shorter the wavelength of the wave, so the smaller that distance it takes for one oscillation, the more the wave will be bent by this refraction. So the shorter waves get refracted further than the longer ones. And that means that blue light, which is a shorter wavelength, has been refracted more the red light, which is a longer wavelength. And it's only a small effect. They've only been separated a few millimeters here, but it's enough for us to see a rainbow. Now that's what happens in a raindrop, and I'm going to demonstrate just quickly how a raindrop would happen. We've got one more piece of glass. This one is round shaped. It's not quite circular, but we're going to look at this, and I hope you can see. I've just got to turn this and get it at the right angle. Here we go. So I've got the beam of light coming in, and I hope you can see it coming out the side. It's not super bright, this one, so you're going to have to watch real carefully. Now, a rainbow happens if the sun is behind you and you're looking at some water droplets in the air, so in a cloud or in falling rain. The light goes into the water droplet, gets refracted so the colours separate. The light reflects off the back of the water droplet and comes back out again. So the light is being reflected by the water droplet to you, but because it's been refracted, the wavelengths separate out and you can see different colours. Very cool. So that is a brief explanation and demonstration of refraction.